get started. I want to definitely thank Karen for arranging this. I'd also like to thank Joe St. Save and Eric Ziast of our research team. They are, as usual, instrumental in piecing together talks like this. I also want to give a warning that any of the live demos I do and some of the screen captures I've got are based on actual live data. This can mean some embarrassing things. Sometimes there's inappropriate things that could be offensive, or we may, run across domains that might be malicious. And I just warn anyone who is inclined to follow any of those particular links to follow the appropriate precautions, please. Don't need anybody getting pwned on my account. From an agenda perspective, this will be pretty straightforward. We'll do a brief rundown of DNS and passive DNS, just to make sure everyone's at the same basic level. I'll talk you through quickly setting up DNSDB Scout. We'll also discuss some of the other integrations we have available. Then we'll dig into the mechanics of flexible search, how to actually formulate the queries you want to make, the capabilities, limitations, things like that. Throughout the whole talk and beyond, we'll include some examples and use cases, but we'll dive into some more specific use cases further on, and then we will wrap up. So we have quite a few use cases. The use cases listed here are really selected for the sweet spot that makes flexible search the most powerful. Phishing, brand protection, drug enforcement, journalism, I would add academic research to that. The first three really revolve around the idea of confusables or creating domains that are suitable for tricking people, tricking them into thinking they're on a brand's legitimate website, tricking them for thinking they're putting their credentials into their bank's legitimate portal, thinking they may get a legitimate pharmaceutical product out of it. Investigative journalism goes deep into things like we worked with a number of journalists who were looking at the last election, looking for lookalike domains and matches. We've also spent a lot of time working with folks looking at COVID, fake vaccination sites, things like that. The idea that you can judge a domain by its name is quite powerful in the universe. And one of the ways flexible search can help is really helping you find the parallels that are going to link you to the activity your specific use case is looking for. So when we're searching passive DNS, we're looking at publicly available data. Someone somewhere set up a name server, an authoritative name server, and published DNS information to it. They publish that information so that users or customers or whatever they want to call victims would be another word, out on the internet can reach their resources by name. Having that information publicly available is what makes the internet work. If you needed special permission to look up Facebook, I don't think it would be nearly as popular as it is. I call it out as it's important when you think about the data you're looking at. It's conceivable to look at this data and think, maybe the actor I'm following didn't want me to know this. Well, it's very plausible. At the same time, they published it. They made it available to a large audience. They made it available to a server that was answering to anyone who came to ask on the internet. So from my perspective, it's public data. A second aspect is history. I think of DNSDB as my DNS time machine. It allows me to look back, 10 or so years and see evolution and history. My favorite example of this is the case where we found a malicious actor had used their personal vanity domain I think it was for a C2, after they had gone through the trouble of setting up privacy, who is privacy, and use bulletproof hosting and dynamic DNS, all the things you try to do to hide who you are. But looking back in the database, we found the year where it was hosted at their university on a system with their name on it. It's not necessarily a link that will hold up an entire case, but it's a really good start in terms of an investigative jumping off point. So, the last 2 points are really looking at how DNS artifacts on the internet interrelate to each other. Very often you will find items in the same neighborhood behaving the same way. Sites on the same web server are either scammy or malicious. Sites that are sharing the same top-level domains, you can often tell by just the top-level domain whether you expect something to be scammy or more legitimate. And that continues on things like shared records. So maybe, imagine a name server. You could have a name server serving a less than reputable hosting provider. Sharing those connections gives you good starting points for your investigations. Before we dive into the DNS, I like to warn people that it is massively complex. As of 2021, there are somewhere in the neighborhood of 3,500 pages of RFC. It is a very deep rabbit hole. I am surrounded all day by people who have read large percentages of that stack of RFCs, and there's still things to learn. So I don't imagine that I can make you a DNS expert in 90 minutes, but I'm going to show you enough to understand what you're seeing when you're looking at DNSDB results. So the structure of DNSDB and passive DNS in generally follows the same structure of the DNS. I like to think of it as a giant distributed key value store. The key, or the left side, or the RR name, also called an owner name, is the domain you're querying. The domain, the host name, the fully qualified domain, all this, the same thing in this case. The key that you are querying for. The key also includes a type. So we've got 2 examples here. We've got FARSIGHT'S NS as the type, stands for name server. It's the name server record that tells us where we can find more information about that domain. The www.farsightsecurity.com, the A record, is an address record. It's telling us where we can find the IP address. So we've got the left-hand side, which is the query. We've got the right-hand side, or the R data, which is the answer. In this case, RR stands for resource record. So unlike DNS, where you can only ask questions about the left-hand side, passive DNS captures both the question and the answer, aggregates that into a database, indexes it, makes it available, and allows you to query in either direction. So unlike the real DNS, where you can only look up a name, passive DNS will allow you to actually look up, show me all the names that have ever been associated with this particular IP address, or show me all the domains that have ever been associated with this particular name server. That the power of that pivot gets a lot of the function of passive DNS. If you've ever spent much time staring at DNS, you usually get to this graph. The main thing to keep in mind is it's hierarchical. Dot or root up at the top. Those are a set of servers run by a select few who are responsible. That's the starting point for all DNS queries. Any recursive resolver that doesn't know where to find .com would ask the root servers and be directed to .com. Each one of the black lines there is a delegation. So the root server is delegating to com.net.org and the other top-level domains. Each of those top-level domains has a set of name servers that delegates to subdomains under it, and so forth. The key point I want to convey here is when we're working with flexible search, it's important to keep in mind that the dot, the root of this, is a real thing. Most clients and browsers are perfectly happy to accept a host name that may or may not include a trailing dot. In some cases, depending on the search you're trying to run in flexible search, you may need to be aware that that's there and you may need to include it. DNSDB itself can live with or without the dot, but because of the way the data is structured, sometimes when you're doing flexible search, you need to actually make sure that that dot is in the right place. And that's actually a helpful tool for specifying whether you're actually talking about the end of a domain name or if you're talking about something, some subset of the domain name. We talked about A and NS. Here are some others. So A is for IPv6 addresses. The quad A, I'm sorry, A is for v4 addresses. Quad A is for v6. MX talks about mail servers. TXT talks about pretty much anything you want. It's essentially a blank record that you can fill in with text. CNAME is a tricky one. You may actually get that back when you're looking for an A record, and it's referring to another host name that you need to do an A record lookup on. These are what we call the top 7. There's a big long list available of all the types. DNSDB captures them all, but these are, if you know these, you're in a good place to get started. So the graph over on the left here, the 3 stack, authority server on top, recursive server in the middle, and client at the bottom, is probably the easiest way to understand what's happening, how we look at the DNS in order to create passive DNS. Clients on the bottom is anything that's going to make a DNS query. That could be your phone, that could be your car, that could be your laptop, anything with an internet connection. It's going to make a query based on where it's been configured to ask. That's usually either your ISP, your local network operation, or sometimes people change that out and point it to something like Google at 8.8.8.8 or any of the quad name servers. The recursive resolver is there to answer client queries. It's also there as an abstraction layer. If every client reached out to the root authority servers asking where .com was every time they had a question, the internet would melt into a puddle of goo. So we rely on the caches in the recursive resolvers to distribute the load. If a client asks a question of the recursive resolver that's been recently asked, that answer will come from the cache of that server. And that cache is a very powerful tool. So first, it's going to prevent information about the client from reaching the authority server. If it's carefully placed, usually by the ISP, all the clients behind that recursive resolver ask all of their questions to it, and it's going to ask what we call cache misses of the authority server. So anytime it can't answer the question from its local cache, it's going to ask the authority servers. Now that may mean one query to an authority server for a single query from a client in the case of something that's very rare. At the same time, a lookup for google.com or twitter.com or facebook.com, there's probably tens of thousands of client lookups to that one cache record before it expires. So this is a very powerful tool in terms of managing data flow and volume, but it also prevents the transmission of PII. Because the recursive server is in the way, the authority server doesn't know who's asking the question, doesn't know what site they were at just prior. It doesn't know who they are. This is part of the reason I encourage people to either run local recursive resolvers or find nearby trusted networks that will let you use theirs. Shipping it off over the cloud, out to the cloud, is an interesting way to claim privacy while shipping your entire query stream off to somebody else. So when Farsight collects our data, we collect it from our sensor operators between the recursive servers and the authority servers. I don't want individual user identifiable information. What I'm really looking for is the map of the internet. I want to know what IP addresses are associated with what domain names. I don't necessarily have any value in this system for knowing who asked what question. There's a whole other discussion to be had about network operators such as IT teams running what we'd call below the recursive passive DNS. It's a perfectly valid tool in an environment where there's no hard expectation of privacy. It's great for finding patient zero, which machine first queried that botnet, things like that. So at Farsight, we collect the sensor data, we send it to our security information exchange, a real-time processing platform. do a bunch of processing work on it, and set it into DNSDB. The volume of that data is somewhere in the neighborhood of 300,000 observations per second. If you normalize that and deduplicate it, somewhere in the vicinity of 200,000 new domains a day. All right, so we'll see in a minute an example of a query, and one of the things it has in it is a count. And the count is the number of times we have observed that particular record from all of our sensor network. As I said, we're monitoring above the recursive resolver, which means we don't see individual queries. So that count, and every count of one could represent somewhere between 1 and 100 million DNS lookups by end users. So we've got to be careful that the count is not an atomic value. It's not something you can use as a specific number. So 3 versus 5 is not useful, whereas 4 versus a million at least tells you something. At least gives you an idea of the scale of things. Our sensor network is global. We've got somewhere in the neighborhood of 500 name servers instrumented. We work with a number of sensor partners who ship us their above the recursive data, process it in many ways. We have a specific environment just for Europe so that we can appropriately manage GDPR privacy concerns. It's actually an entirely separate enterprise, and we pull that in. We are always interested in more data. If someone is interested in running a sensor, please feel free to reach out to us. We'd be happy to talk to you. The other thing I will add is if you are using passive DNS for your own network operation defense, I encourage you to run a sensor. On the off chance you are attacked by something specifically targeted to you, it's very helpful to make sure that all of those observations are in the database and available to you. Otherwise, it gets uncomfortable. So in the case of our passive DNS system, it is not reputation. I don't claim to tell you whether something is good or bad. Spent about 8 years in the reputation industry. I have learned from the error of my ways, and I focus on providing tools that help people develop their own reputation, develop what bad or malicious or block-worthy means to them, and implement it directly in their environment. I've just seen too many cases in my life of, why didn't you block this? Well, it didn't meet our definition of malicious. That's a back and forth that's really hard for anybody to come out on top and win. So, like I said, we don't offer reputation, but we do offer some pretty valuable information that will help you map out what you're looking at, and is very often used by reputation providers to cross-connect and link items that they're interested in. So, like anything, passive DNS has limitations. DNSDB has limitations. We have a limited network. I cannot claim that we observe every DNS transaction that has ever taken place on the internet. There just aren't enough sensors to cover all of it. So we've got to be careful to warn that it's possible queries take place, especially targeted, very precisely targeted attacks, very, very often can be missed by passive DNS sensors. So like I said, it's useful to have a sensor in place. There are some things that we actually explicitly remove. DDoS traffic just doesn't help us having it in the database. Encrypted tunnels, we tend to pull those out. We often don't capture references between ISP dynamic space and their IP addresses. We would capture things like dynamic DNS pointing to an address on dynamic space, but we won't necessarily keep track of all the ISP internal host names. It just changes a lot and doesn't change much. We also do not include databases in DNS as a rule. So there are plenty of blacklists or block lists that appear via DNS. Where we are aware of them, we filter them out of the database. That's somebody's livelihood. We don't necessarily want to mess with that. We also do exclude privacy sensitive information. There are a handful of content delivery networks that include way more information than the end users might realize when they're clicking on links. So in those cases, we do filter that stuff out. And we don't currently have a foothold in the dark web or Tor or anything like that. So we don't explicitly capture that kind of information. There are plenty of other folks who focus on that target area. All right, so with that being said, you have all, in theory, been invited to sign up for a 30-day trial, 100 queries a day. The way that's structured is you get 100 queries for a 24-hour period. At the end of that 24-hour period, another 100 queries. Your total available resets to 100. So they don't roll over. That's takes place at midnight UTC. If you've had an issue obtaining your key, Karen's available on chat, and Karen could actually drop into the chat if she wants to, the link in case anyone hasn't. All right, so there are a number of ways to use DNSDB and Flexible Search. We used to have a username password based tool that was a web interface that has been deprecated. Now everything, the only way to access DNSDB is via the API, but we have some fun new tools for using that API. We'll talk about the command line tools in a minute, talk about the web-based tools in a minute. I did want to mention that we have quite a list. This is just the first page of our integrations list. So we've got a number of integrations with existing platforms. So if you use any of these, I believe all of these can handle, if you plug in your API key, you would be able to use FARSIGHT passive DNS data directly in those platforms. I don't believe all of them are up to speed on Flexible Search yet. I know Maltigo is waiting for me to review and update, but it's coming. It's in process. So we talked about command line client. There's one for DNSDB, which is called DNSDBQ. There's the link to GitHub for it. It's a C program. I believe we've got packages in Debian and FreeBSD. In fact, it won't be long before we have the Red Hat packages pushed out. There is also a DNSDB Flex client tool that is specific to Flexible Search, and I forgot to put that in here. The command line is pretty straightforward. In this case, it's doing an RData query for read.edu. The -J says, give me JSON output. I'm a big fan of passing things into JQ and slicing and dicing after I've pulled it out of the command line. The next tool I'll talk about is DNSDB Scout, but I should point out an important difference between the two tools before I do that. Difference here is DNSDBQ and the command line tool stream the results. So as you make a query, as the answers come back from our database, they will be processed and output, except if you're doing client-side sorting. Those get output to your display or your pipeline essentially in real time. DNSDB Scout, on the other hand, gets the entire result, sorts it, and displays it. It turns out that the overhead of rendering, constantly re-rendering a large data table gets to be very painful for the browser, and you crash browsers, and it's not fun. People aren't happy. So there are a couple different ways to get Scout. Scout.dnsdbinfo is probably the easiest. It is a web-based tool. In this case, it is the exact same code that is available via the browser-based plugins. So Chrome, Firefox, and I think we have Edge now, plugins for DNSDB Scout. It's the same code. It just, it's rendered locally instead of being sent from this website. But if you want to try it out, scout.dnsdb.info is a great place to start. I'm going to step through here how you get your API key plugged into it, just in case you want to follow along with some of the other queries as we go. To set up, all you need to do is hit the cog, the little gear wheel there. You would plug in the API key, hit the save. There are some other opportunities available under the Advanced tab, theme mode. So there's a normal, like an inverted color thing. It's not going to do that. Yeah, inverted, dark mode. It tells you more about your query, points you to the API docs, things like that. So you'd save your API key, switch over and hit a search. If you come over to search, right now, there are 3 tabs. There's the flexible search, the standard search, and the recent queries. Recent queries actually holds on to all the queries you've made recently, so you don't have to wait for them to render again. You'd be able to go in and select view from one of the previous queries you've done, or actually rerun it. The other useful thing with recent queries is if you're trying to build an API integration, it'll actually tell you exactly what query it sent to the backend. So it gives you kind of a debug and development tool there. So we have, on the standard search, we've got 2 modes. We've got RR set and R data. RR set is going to be the forward left-hand side query. R data would be the right-hand side query. You've got a limit here. So by default, on the web version, it's going to give you 5,000 results back. You can select anything from 25 to, I believe, 50,000. And you could select a record type. So if you're only interested in IP addresses associated with this particular domain name, for example, you'd select the A record type and hit search. So the answers this is exactly what I got back from this. So we've got a triple of first seen, last seen, and count. So we've got a range of count from 127 million to 2. Bailiwick is, if we were to go back to the hierarchical graph, bailiwick is what domain was the server responding responsible for. So in this case, the server responding, according to DNSDB, was responsible for example.com. But in this case, it was responsible for .com. So this is the .com TLD server responding to a question about, for an A record for example.com. You'll note they have exactly the same IP address. All right, so with the first seen and last seen columns, you can look and see kind of the history as this evolved over time. So what was it, July 2010 is when the database started. Good for about, that first address was good for about a year. The second address there was good for a couple years. And then we continue on from there. So this is our time machine. This gives us the history of what's going on. It's important to, when you're looking at the count value, to also look at the time value. If the count was a large number, but the time span was only a second, that might be interesting. If the count was a tiny number, but the time span was only a second, that might be less interesting. So let's look at a live example. So PayPal secure.xyz is probably not actually PayPal if I were to bet. So we could look it up in DNSDBQ. All right. In this case, Joe, who helped me with these slides, likes to defang things so people can't accidentally click on them. That's admirable. So, PayPal secure.xyz/A. That /A indicates we only care about A records. In this case, we get back 1 record. It was seen by our backend 98 times and a single IP address. So in DNSDBQ, we can do a pivot, look for -I indicates I want to see the IP address. So 198, 187.31. So this is the list of host names associated with that IP address that include the word PayPal. So chances are the list was substantially bigger than that, but as it got stripped down, it now only includes PayPal. So I'm going to, should be the same address. So that's what the result typically looks like. So it's in the same form as the DNS record. It's got the host name, type, and the R data. So we can vary, COVID-19's in there. So let's see what that looks like. Just the one. Okay. I probably had a different limit than what Joe was using when he made that slide. So we've got the example there. So now we could take, let's see what else is associated with that particular host name. All right, so it's had a couple different IP addresses, and again, we could pivot. We could do the -I, pivot onto those other IP addresses, and go to town. I'm going to show you the same thing in Scout, just so standard search. In the case of an IP address, I switch over to our data. And search that. And so much the same. We're seeing the same information, just presented in a different way. So these columns here, you can sort by a particular column. You can sort by our data. The really cool thing with the DNSDB Scout is that I can click on any one of these links here, and it's going to perform a pivot. It's going to do that particular search. And we can see what we've got there. So we've got some other IP addresses. Maybe this one's interesting. Bunch of host names. So it gives you a chance just to kind of see. I just wanted you to see what it looks like. So in terms of flexibility of search, DNSDB itself is rather limited. The main function that adds flexibility away from precise matching exactly what you entered are wildcards. But the wildcards, in terms of their capabilities, are pretty specifically limited. So in DNSDB, you can do what we call a left-hand wildcard. You do star.something, so star.example.com will give you all of the host names and subdomains under example.com. And you can do a right-hand wildcard. You can do example.com.star and get all of the other TLDs that particular domain may exist in. You can't mix them, so you can't do both. You can't do star, example, star. But you also can't do partial labels. So you can't, the asterisk has to be all the way up against one side or the other, and the next character has to be a period. That's the only way in typical DNSDB that works. Give you an example of that. If I do paypal.com.star, as much as I hate picking on PayPal, there are a lot of domains out there pretending to be PayPal. So we've got some examples here of what came back. I assure you there's a much longer list, but you see paypal.com.something. You'll note here in DNSDB, we do have another source of data, and that source of data we call zone files. There's a number of services that make available the top level domain zone files. So that's going to be .com, for example. All the domains under .com are available in this format. The records with an asterisk, and I think on this page they all have one, indicate that record came from a zone file. If it doesn't have an asterisk, it's passive DNS. If it does have an asterisk, it came from the file that generated it, that particular zone. So what you're seeing are in this particular case, are a set of zone file records. And this is actually a pretty close approximation to when that domain was registered, because the moment it appears in the zone file is the moment it gets registered, and the moment it disappears is the moment it is no longer an active domain. All right, so let's go down the road and expand past just the super simplistic wildcards and get into flexible search. So it uses the same general API, different endpoint, but on the same server, on the same same access area, and you'd use the same API key and quota. We've got 3 types of flexible search. We'll cover all of those in a minute. There are lots of cool things you can do. If you find a DGA regex pattern listed in a blog post, you can plug that right in and run it. If you are looking for similar but not identical patterns, we have our regular expression pattern matcher is pretty advanced and can do a lot of cool things. You can also search for things that are not necessarily on one end or the other of, say, a text record, for example. You can do deep searches into the R data. I will note we don't include IP addresses in flexible search. Those are very rapidly available in DNSDB. There's limited value in using them, making them available in flexible search, because really what you want is the mathematical, the ability to search by CIDR block and things like that. One limitation of flexible search is that it only returns the host names that matched, or the R data that matched. In DNSDB Flex, we make it easy to click a link and pivot over and get the whole record from DNSDB. Well, once you have the name, that comes back super quickly. But this allows us to, run this particular search engine much faster. I will note the trial keys you have will, as a result of this webinar, will perform flexible search queries, but our freely available DNSDB Community Edition keys do not include flexible search. That's just kind of an advance warning there. All right, so when we talk about flexible search, there are a couple elements of the mechanics we have to discuss. One of them is anchoring. If you're familiar with regular expression, you're pretty comfortable with this idea. If you're doing a search in Google, that is by default not anchored. If you put in a search term, it's going to find that term anywhere on the page. If you do a search in classic DNSDB without any wildcards, that is a fully anchored search. So if I search for example.com, as we did earlier, it's only going to give me answers for example.com. If I put a wildcard in, star.example.com, it will give me more. It will give me other things that grow to the left of that name, but it won't include anything that is longer to the right. So as you're working through the various types of flexible search, it's important to understand how those types anchor and where you need to worry about that. This is where the trailing dot comes in. Talk about it more when we get to the specific types, but just be aware most of the modes have a way to specify, I want this to be the whole term. I want you to match the length exactly, or I want to include things that are off to one side or off to the other, or both. There are two query types, much like DNSDB, but they're named slightly differently. So in DNSDB, when you search by the owner name, the left-hand side, we call it RR set, because you get back the query and the answer, the full resource record set. But in flexible search, as you're only getting the RR names back when you do that type of query, it's called RR names. And then we have the R data type. So you can search in the answer. You can search in text records. You can search in NS records, things like that. The DNS is not case sensitive. So everything is case folded down in DNSDB except for R data. There are some cases where R data, like text records, case actually matters. But in host names themselves, it does not specifically matter. Also, we only include printable characters and space in the data set that we're looking at here. So I'm going to show you an example of a keyword search. So before we did paypal.com.star, and we got things that started with paypal.com. Here we've switched over to flexible search. We're in keyword mode and we're looking at left-hand side. We're going to search for A records related to PayPal. Now this is going to match, keyword is not anchored. So it's going to match anywhere in the string, might be the beginning, might be the end, might be the middle of a label, might span a label, all kinds of fun things. So there's an example of what you get back. So you can find in there, PayPal is kind of stuffed in the middle of some of these, some in the end. It's a pretty long list. It will go on for a while. So it's going to be important to learn the tricks to filter that list down and increase the accuracy of your search pattern to get the best end result. There are three modes. There's the GLOB mode, the keyword mode, and the regular expression mode. Keyword is actually the most simple, but I'll explain later why it's after GLOB. GLOB is going to be reminiscent of your days with a Windows or Unix command shell. And anyone who's done a lot of regular expression should feel, right at home in the regex mode. So as I said, GLOB, it's the same style of imprecise search that you would find in a command shell. So if you're, cat star.txt or, edit autoexec.star back in my old DOS days, those stars are expressing a GLOB type search syntax. By default, globs are anchored on both ends. So when you say star.txt, that star can mean anything. In the case of a file path, it would be within the current directory. The star.xls would match files that are star.xls, but not star.xlsx, the new format. This is why that trailing dot is important. So in the case of a DNSDB Flexible Search GLOB query, if you are not unanchoring the right-hand side, you do need to include the dot. We have a very nice reference guide available on docs.dnsdb.info. We've got one for GLOB and we've got one for regex. This is going to go into substantially more detail than I'm going to go into today. It's going to talk about all the classes and all the various forms of search you can do. I'm just going to give you a high level to help steer you in the direction of the one you want to learn more about when the time comes. So in addition to star, which matches 0 or more of any character, we've got a couple other command options here. Question mark is going to match exactly one character. So if you're looking for something like example, but the L may be some other, it may be a 1, it may be an I, you could put a question mark in the place of that character, feed it into GLOB, and it's going to run that particular search. Character classes are a little more involved. It's the idea of, I'm going to replace one character with a set of characters. I'll give you an example of this one in a minute, but the idea would be, if you wanted, let's go back to the example.com with a character other than L, you might, do open bracket, I, 1, L, and then close bracket. So as you do the search, any of those possibilities would be acceptable in that position. There's something called a negated character class, which means I want anything but that character. I'll show you an example of that in a minute. And then there are POSIX character classes. These are predefined groups of characters. Digit is one of those. So open bracket, colon, digit, colon, close bracket would match any number. Square bracket ends the character class, and the backslash escapes the character. So if I were searching in a text record and I had to match a literal question mark, you need to precede that with a backslash so that the interpreter knows I don't want to replace any character. I actually want a question mark here. Okay, so here's an example. It's using a simple character class. So we're using flexible search, globbing, left-hand side. And the search in this case, looking back at our earlier example, ns5.dnsmadeeasy.com. Let's see what happens in 0 through 9.dnsmadeeasy.com. Case we'll look for A records. You get a pretty predictable list. You'll note you don't get 10, 11, or 12. If you wanted 10, 11, or 12 in this case, you actually have to specify, okay, I want 0 through 9, and then 0 through 9 again. We can run that search, and now we get the additional set. Regular expression is a little better here in terms of you could do both with one command. But now you can kind of see how this gives you the ability to search for things you're not even really expecting to look for, things you don't know you're trying to find. Here is an example of a negated character class. So you'll note I've got an asterisk on both ends, so I am not anchoring it. I am explicitly unanchoring it, so this can occur anywhere in the string. And it's FARSIGHT security, but anything but an F in the beginning. So if I look that up, star site, clear site, those are the two main examples. But so you get the idea. I knew most of the string, and maybe maybe I work for Farsight. I don't necessarily care what's about Farsight security. I want to see where other people are trying to use the same name or try to impersonate the name. All right. So the reason keyword was second in the list is it's kind of a dirty little secret. It's actually just the input you pass to GLOB. It only appears in Flexible Search via Scout. DNSDB Flex command line doesn't actually include the keyword option, assuming anyone who's doing things from the command line would just realize, do a glob and put an asterisk on each end. Specifically in this case, the trailing dot is not required. No other special characters are allowed. They're actually, blocked, but it's worth noting that this is a pretty noisy search in that sense. It generates a lot of hits, so the longer your term can be, the more successful you're likely to be in finding what you're looking for. Let's pop a couple examples here. So if I switch over to Flexible Search, keyword, and do Farsight. So this can take a second. Remember, it's getting the whole, in this case, a little over 5,000 results. In the case of Flexible Search, sometimes you'll set a limit for 5,000 and you'll get more answers back. That's mainly because you're getting multiple hits against the same name. They show, you'll get 5,000 results back. It's just the way it's counting, it's seeing the same string multiple times. These are all different types. So A record, NS, SOA, there's a full set there. So yeah, you can pick your term and dive in. farsightblogger.ai. So you're waiting for the entire set of results to come back. But that means you can actually switch through the pages really quickly because it's all actually cached in your browser. And we can actually go recent queries and look at one. So yeah, we can view a query we've done before. Recent history pops right through. Other things to know about this interface, you can change the number of entries per page. If you are encountering internationalized domain names, there's an option here. This to Unicode option would actually let you switch it to a Unicode interpretation as opposed to the puny code, the XN business that's very hard to read. So, if you're digging around in the right places, you can find a few domains that have emoji built into the name. You also have the option to export things. So you can pull it out to CSV, you can pull it out to JSON. You can filter things. So if I go back to the query we just ran, that one, I can filter the type for CNAME and then export just the filtered set or export the whole set. So again, the longer the term, the better. No special characters in keyword, and it's going to be explicitly unanchored. That term can appear anywhere in the string. If you want something more specific, obviously it's pretty easy to go into GLOB and do it there. All right, so regular expression is I don't know, I was gonna say how long I've been steeped in regular expression and I've lost track. It's probably been 20 years at this point. It is a way to describe pattern matching. And purists can do some pretty impressive things. There are variants of regular expression that are bordering on Turing complete and can actually be programmed. The version available in Farsight's Flexible Search is explicitly limited in a couple different ways. Only printable characters are allowed. We don't currently allow octal or hex escape sequences. We limit the scope and type of the POSIX collating elements and the POSIX character classes. And we don't currently allow the / notation. So in traditional regular expression, \W would be letters. \D would be digits. That's not currently allowed. We call this Farsight compatible regular expression. It's a play on Perl compatible regular expression. The other thing that's probably most painful for aficionados of regular expression is we don't offer back references or capture groups. We don't really have a way to present the result of the capture groups, and the back references is the idea that you can match something early in the string and want to match that same thing later in the string. And that's just adds a level of complexity that makes it hard to return performant results. So again, we have a nice reference guide. It's got all the details, goes very deep on this particular topic. We also, at that same site, have very detailed API documentation for both DNSDB and flexible search in general. Highly encourage anyone wanting to do more work with flexible search to pick those up and give them a read. So in terms of syntax, it's a little more complicated than GLOB, but relatively in the same vein. Backslash to escape. Unlike GLOB, dot in regular expression is a special character. So if you use dot without an escaping backslash, the interpreter will take that to mean you want any character in that position. If you want a literal dot, you do need to escape it. By default, regex matching is not anchored. Whatever you feed in will appear anywhere in the string. You can use the caret or $, caret for the beginning of the string, the left-hand edge, and $sign for the right hand of the string, to indicate that you want that end of the string to be anchored to the end of the match. If that is the case, and you're using the $sign, you do, in this case, need to have a backslash dot at the end to match that. Just like GLOB, we've got character classes in regex. Dot is any character. I'll give you an example of subpatterns here in a minute. Subpatterns may be nested. That gets pretty complicated pretty fast. The vertical pipe symbol is an alternative separator. When I read through a regex, I would say OR when I get to a vertical pipe symbol. Unlike GLOB, where star means 0 or more of any character, in regular expression, it means 0 or more of the previous character or class or pattern. So if you want to specify 0 or more, if you want anything after a term, you would type dot star, dot being any character and star being 0 or more of the previous character. Similar to GLOB, question mark is at most 1 of the previous character, but possibly 0. Regex adds plus, which is at least 1 of the previous character. We can also specify a specific number. If you want something 37 times, you would open curly brace, 37, close curly brace, and that would match. If you have a range of the number of times you want to see something, open curly n comma m, n being the lower bound and m being the upper bound would allow you to do that. Digging in on the PayPal example a little further, we're going to anchor to the left-hand side of the string. So whatever we search for is going to start with the word PayPal. Dot star, meaning anything, not necessarily a dot following PayPal. It could be any other word. It could also be nothing. Star is 0 or more. And then one of the word secure, protect, fraud, or scam. I could actually put, say, a plus sign after that and 0 or more of those, but we'll run this as is. So again, flexible search, regex, left-hand side, there's our string, searching for A records, and here are some examples. So we got PayPal secured, PayPal protection, PayPal zone secured, and on and on and on. So the idea here is you can take a search that may be giving you a bunch of junk and add terms that make it more precise for what you're trying to accomplish. And you continue to evolve that as you go. This is the DGA example. So very often when you are reading a blog post about a new piece of malware or a new Trojan or something like that, and they talk about a domain generation algorithm, The idea that this particular piece of malware is going to come up algorithmically with the domain name and treat that as its command and control server. And the attacker is going to follow the same recipe to figure out what the domain name should be and then register that. This was originally created, first time we saw this in major use was Conficker 10 years ago. But what you'll see very often in blog posts, in industry blog posts, is a regular expression string describing, you know, what was determined when they reverse engineered how that algorithm works. What are the possible, this is going to describe the possible set of domain names available to that particular family of malware. We've got, what, 4 families in particular here. Now, there's some translation needed. So, for example, in this case, you've got capital A, you know, got a character class including 0 through 9, capital A, capital Z, lowercase a, lowercase c. You don't need the cap A, cap Z anymore. Flexible search doesn't actually, you know, it will pay attention to it, but it will be replaced by the lower a, lower z. In this case, it's going to be 8 of those characters, a real dot, and then this domain name. So ideally, what I do here is also add a closing backslash dot and then a $sign to indicate, you know, no, I really do want this to be the end of the string. This one's interesting. It's a character class of 3 characters from A through H and J through Z. For some reason, no letter I, not sure why. A literal letter Y, and then 3 more A through Z. Okay, so that's pretty specific. Some of these are very unspecific. You know, B through Y, 12 characters in .com, .in, .net, and .ru. That's not going to be terribly useful to you, and that's probably intentional. So let's look at an example of that. So these are how I'd remap those particular, a handful of those particular queries for use in flexible search. So I've added the backslash dot to the end of all of them and a $sign, and I've added a caret to the beginning, just so that we anchor cleanly and reduce, you know, any extra noise. What I would often do is search one of these, and then walk through the list of results I get back and see if I can find a pattern in terms of name servers or infrastructure that might indicate, hey, this is actually the real, you know, the real botnet, or if this is maybe a wildcard, or if this is something that just got caught up in the regex match, and then go back and, you know, do some more searching, figure out where things went wrong. So here is one example. The title here actually capitalizes everything, but that's okay. In this case, it's very likely that, you know, that particular domain has some special connection with the operator of that particular malware. And we've got another one here. Okay, I don't know what that thing's problem was. All right, so yeah, we've got, now as I said, in flexible search, you're limited in what comes back. In this case, as an RR name query, you get the RR name and the type, but you can click on any of these. It'll bring you right over to DNSDB with the full suite of information we have. Not too long ago, we launched FARSIGHT Labs. This is a dedicated members-only environment. It's free to sign up, but it makes available to you early access prototypes, tools. There's a community there talking about, you know, interesting things we can look at, and you know, trying out some of our non-production tools and services. There is a version, you can find that at labs.fsi.io. Again, it's a free thing to sign up for. If you do sign up, I highly recommend you check the box that Karen every day does a daily roundup. And it's just a rundown of interesting net security, DNS related news. It has replaced a number of news feeds I used to follow on a regular basis in terms of just kind of keeping situational awareness. If I go to labs and I go to, so there's a bunch of different tools here. The one I'm going to show you is called Scout EN. EN is short for EXPANDNAME. This is a quick little hack together tool, the new tab here. But if I put in, so first I'm going to select a couple different algorithms. I'm going to select QWERTY and LEET and put in, so this is going to generate regex patterns for one for each character in the input string based on these algorithms. So QWERTY says, look at the keyboard and what are the most likely keys to typo for a given letter. For example, if you're looking at, say, a W, Q, E, S, A, and 3, for example. If you look over at LEET, it's going to replace, E's with 3's and, L's with 1's and T's with 7's, for example. So here are a bunch of examples. And now I can just click. Actually, I'm going to turn on novel, which means I don't want the original string included in the output. And let's click this guy, see what we do here. So this is a way for me to, very quickly generate a pattern to search for and pass it into flexible search. So this is what, second to last character was something different. And it's doing a regex match, based on that string. So that's a pretty useful tool in terms of finding things to search for quickly. There are a couple other fun things. There's actually a GUI for the expander. I can say, let's see, QWERTY, LEET, FARSIGHT. You get a bunch. You get it right there. You've also got it combined into one OR string. So highly encourage you to check that out. All right, getting into the home stretch here. It is worth paying attention to when to use DNSDB versus when to use flexible search. If you know the exact RR name or the exact RR data you're searching for, DNSDB is very likely going to be faster for you. It's going to hit the index and get exactly to where you want. If you can satisfy your search with just a left-hand or right-hand wildcard DNSDB style, it's probably a toss-up. If you need to search for an IP address or an IPv6 address, you very likely want to go to DNSDB. However, if you've got a regex, you need a wildcard or a specific pattern in the middle of the string, or you want a more advanced pattern against our data matching, definitely need to go to flexible search. In terms of performance, my recommendation is to anchor wherever possible. There are definitely times where you can't anchor to find what you want, but if you can anchor, usually you get things faster. Limit the scope of OR terms. Going back to like this example, pasting that into flexible search will work, but it will probably take slightly longer than doing each of the terms individually if you were using the API. It's just because of the way it aggregates the pattern space, searches it all, and then pulls out candidates that match. In general, the longer the match, the better. Remember that everything's case folded, and definitely don't forget trailing dots when you need them. Some takeaways. Labs is definitely a cool place to check out. If you do need support or help, support at farsightsecurity.com will be happy to assist you. We've got plenty of resources under the resources page, or DNSDB.info has most of the resources you'll need as well. Joe St. Sauvey and a number of my team do fantastic blogs about in-depth analysis on very specific angles of DNSDB and how to use it. It's worth a search if you're trying to solve a specific problem. If you are a researcher, an academic researcher, an internet superhero, consider checking out our grant program. We do a lot of grants, and we try to make sure that the people who need this data have access to it. We've also got the free community edition. It's more restrictive than the 30-day trial you've got, but it runs longer. Obviously, we also have commercial services if there's a discussion to be had there. As mentioned earlier, we do offer discounts for folks who contribute data. Put a couple questions in here for homework if anyone is interested in that. Karen will make the deck available, or the recording will be available. Just a couple different puzzles to think your way through. Be happy to discuss these with anyone if there are questions. Some more resources. I think this is the end. The docs again, labs again, and then we've got 2 more upcoming brown bag sessions. My VP of engineering is going to do DNS for incident responders. And I think that's, Boris, is that you doing DNS search for cyber investigations?
Yes. Yes, that is correct.
Awesome. And that is what I've got. Do we have questions? So we've got a question. Have we seen any ML models built on PDNS to date? How successful were they? And reciprocity. All right, so ML models, yeah, we've seen a number of folks building ML models. I don't have specific numbers on the, or can't share specific numbers on the effectiveness of the commercial stuff. There are a handful of academic papers that have gone on to build ML models on the data. I tend to find ML has a hard time with DNS data because there are often very few features to latch onto, but there are some folks who have had success with it. Reciprocity and sharing agreements. If you are in Europe, SIE Europe does offer a reciprocity agreement for European data. So if you share passive DNS data with SIE Europe, you are eligible to sign up to access the data. If you act as a censor and share data with FARSIGHT, generally that can result in a discount, and we are happy to discuss options there. And domains on a blacklist, DNS as a database are not tracked. So I'll give you an example. Spamhaus makes their database available by DNS. If you know the right place to query, you can query it and get the answer. Will tell you the IP address that comes back will tell you what Spamhaus thinks of that particular domain. Those in particular, we filter out. I don't specifically share that list because I don't necessarily want people going out hunting for it. Because in part, in theory, the customer should actually, it should be limited to actually their customers.
Ben, I think that pretty much wraps it up for today.
Okay.
And I want to thank you so much for taking your time today to deliver such a great presentation. I want to thank the attendees for spending their time with us this afternoon. Again, if you have questions or like a copy of the deck, feel free to reach out to me. My email address is in the chat. And again, look out for our future brown bags. We have some great ones coming up, as Ben has mentioned on the screen. Thank you very much. And I want to wish everyone a wonderful day. Thank you.
Thank you all.